So I want to again thank everybody that took the time to leave reviews on iTunes. It's really helpful. It gives us a sense of, how we're doing, what you're thinking, and it also gives other people kind of a sense of what they might be stepping into when they join our show. So thanks, appreciate that. Another reminder, all past episodes are transcribed now and published on chairmakers.com. So hopefully that makes it easier for you to reference if you want to go back and look at one of the answers that I gave, or look up something that you'd missed and didn't know about. So check that out. You can subscribe to the woodworking newsletter on chairmakers.com. Right now we're just using the newsletter to kind of fill everybody in on what's been going on and what's coming up with this program. But we will be fleshing that out over time and doing some more interesting things. For future episodes, you can subscribe on YouTube and iTunes and iTube. You'll figure that out. You can also follow me on Twitter at Chairmakers. If you have any questions you'd like answered on the show, again, go to chairmakers.com, Instagram at Brian Boggs Chairmakers, YouTube, comment section, and Twitter, Chairmakers. We got several interesting questions for today's episode. Any one of these could take the entire episode, so I'm going to be a little bit challenged to kind of contain myself. Anyway, we got one on using hand tools to get precise dimensions in joinery of overall parts. Which is an interesting challenge for anybody who hadn't taken that on. I did that many years ago and came up with different ways of doing that. Another listener writes in asking about starved glue joints, which is an often discussed question, and there's a lot of confusion about that, so we'll talk about that for a little bit. Another one asks about scrapers not generating a finish, whereas a hand plane or a spoke shave or even a draw knife can get a clean cut. Why not scrapers? And then the last one is on steam bending and lamination questions regarding making things like canoe paddles. Which is the way to go, and what are the challenges? How do you address the challenges of getting the right performance of each of those? And all rich topics, and we'll just jump right in here. So this one's from Paul, and Paul writes, "Hi, using hand tools only, what exactly is the proper way to accurately saw several pieces of wood to the same length consistently from piece to piece?" Well, the challenge with any precision woodworking operation is that your stock prep is your first step for generating a part and, of course, generating variables. Variables are the differences between your target and the real thing. And some people talk about making a perfect joint or a perfectly flat piece, and there's really no such thing. The most accurate thing that we have in this shop is a rock. It's a precision granite plate, 3 inches thick, 2 feet wide, and 3 feet long. And it's registered to be flat within 1.7 ten-thousandths of an inch over its whole surface. And that's a grade B stone. So there are some that are more precise than that. A lot of people will call that dead flat, but the truth is, right there on the certification paper, is they are allowing a deviance or a variable of 1.7 ten-thousandths, and that is done with some pretty sophisticated equipment. So wherever precision is really important, machinists and anyone working in those professions has ways of identifying how much of a variable is allowed or is accepted. So when we're targeting a variable, we want that variable to be created at the stage where we're measuring it or where it's important. So if you are cutting parts to length, for example, and let's say you have a part, just cut once just as an example. Let's say this is your part. This is just a little piece of plywood, but just imagine this is piece of hand-wrought solid wood and it's 15 inches long. I have no idea how long it really is, but let's say it's 15 inches long, nominally. And you're going to cut 15 more of these, and you need to be exactly 15 inches long. Well, exactly, right? So what's critical, though, is not their length, because the length is just going to be the end of a tenon in the bottom of a mortise, and that's not what's going to determine the size of your panel, because there's always a gap at the bottom of that. The critical thing is the shoulder-to-shoulder length. A traditional cabinet making process would be to make this exactly a length and then use a marking gauge to mark around the periphery at each end, and the result is the compilation of 3 variables now. The variable of each part to the next part, maybe it's only 1/10,000th of an inch, but it's going to be a variable. The second is the variable created by holding your marking gauge with your hand and moving your part around here. That's going to create a variable of some measure that varies the distance this is from the end compared to the distance on your design paper. Variable number 3 is the other end. The resulting length between your shoulders adds all those variables together, and that's your overall slop, which is tough, which in my view makes that series of traditional steps not very good. So in all of the processes that we use where that kind of precision starts to pile up, or that kind of variables start to pile up, we try to erase those and start over. So in this case, I would make these a length, and rather than measuring from each of these, I would make a gauge like this. This is very much like a bench hook, but this is just a piece of, just for show and tell today, I just two-sided tape attached a piece of plywood to a piece of MDF, and that's a straight line, and then after attaching, cut it square. I used a chop saw, not hand saws, but never mind. The idea is this is not going to vary each time I use it to measure one piece or the other. And to further protect my precision, I made an identical one so that when these are together, they are flush and square at both ends. This could be made by hand. It could be trimmed and squared at both ends to give you a constant length. And then you could put these on your part. Excuse me? Articulate for iTunes. People listening in the audio. Okay. So you can measure this if you want to at the ends, but you darn near eyeball it, because what's critical is with this clamped together that you're going to cut or mark this around this way and start afresh. So you got a whole new variable here, and with that as a fixed point, you're at least just going to have one variable. What I would do if it really mattered to me is I would actually clamp this together and put the saw against this side and use that as a guide all the way around, and without releasing this clamp, put another clamp here and do that again. And that will give you a much more consistent, fresh new marking point from which to cut all of your parts. That's just one way. There's a lot of other ways, but whenever you're needing to have precision, using, in this case, the shoulder-to-shoulder length rather than the compilation of your tenon and then resulting shoulder length is going to help eliminate a lot of the errors. But that can be taken into really any production process where you need precision. I hope that helps, Paul. So from Patrick Daugherty, on glue joint starvation, he writes, I've heard it said that there's no such thing as a glue-starved joint. I suppose it is to imply that as long as the glue bonds to the fibers, the film thickness between the wood surfaces is not relevant. Do you agree or not? Well, it's difficult to starve a joint. However, if you've got a mortise and tenon joint that's a little too tight, you're going to shear almost all of that glue off during assembly. The tenon is going to push it down to the glue you put in the mortise is going to be shoved at the bottom of the hole. The glue you put on the tenon is going to be pushed up to the shoulder. And you're not only do you have a very thin glue joint or pretty much not enough glue to saturate that surface, but if it's a real tight joint there, you're going to push that joint apart and you're not going to have a good clamped together surface. So it's not just about how much glue is present or how much glue is applied. It is the way that the two surfaces being glued together approach each other and whether or not that action of coming together traps glue in there or shears glue off. This starved glue idea or concern is exactly why I started working with the taper locking joints, because it does trap glue in there rather than shearing it off. In traditional joinery, there is a real delicate compromise between avoiding that glue shear and getting glue bond by having wood-to-wood contact. The tolerance requirement there is very, very tight, and I don't think can be overestimated or over-attended to. So yes, there is such thing as a starved joint, but it's generally only going to be happening in a mortise and tenon joint. And I actually have had that. The place that I had that was on a rocker runner slot that I was fitting tight, and years later the joint failed. And when I looked in it, it was even several years after I had built that piece, it was a perfectly fitted joint, wood contact all the way around, no evidence of wood glue whatsoever. So it was completely sheared off. So that's the only time I've noticed failure due to starvation, but that's one time is enough to prove that it actually can happen. So attend to your precision. Mark's Barabbas, or Mark writes, maybe it's Mark S. Barabbas. I understand that a finished cut or one that needs no additional work prior to finishing can come from an edge tool like a draw knife, plane, or spoke shave. I don't understand why a scraper doesn't produce a finished cut and requires sanding prior to finishing. Can you explain this, please? I would love to. This is a topic that I don't, it's been addressed a number of times, but a lot of people aren't really understanding the scraper versus planing idea. And part of the problem is that it's talked about, and this is a good example. You don't say scraping versus planing. You talk about a scraper versus a plane, but it's tools that are put in some ways in two different worlds, as if one is doing something different to the wood than the other. And generally it is, and the difference is generally very clear. But if in looking at tools that if you're making your own tools, and I think in the example of a bevel up low angle block plane, the options for cutting geometry are almost unlimited, such that you can go from a planing angle all the way up into a scraping angle and past that and play with that geometry and watch what happens as you increase your cutting angle. The reason that the scraper as a tool, and I think you're probably talking about a card scraper, is a card scraper is usually used by, imagine this is a card scraper, I'm leaning the tool forward and scraping in. And in doing that, the tool is pushing down on the wood. And the scraper edge is a very fine line, so I'm putting a lot of pressure on the wood at the cutting point. And what's happening in doing that is, with that negative angle and that downward pressure that the scraper is putting onto the wood, everywhere that a pore emerges through the surface of the wood, it's like a straw. And where it emerges through the surface of the wood, the top edge of that pore or straw is super, super delicate. And there's nothing underneath that delicate edge to support it against the downward pressure of a scraper cutting. So what happens is, where that unsupported wood is it just falls into the pore. And as you go by with a scraper, it can pop back up. That's called raised grain. Sanding does the same thing, because it also cuts with a negative angle. It's got these little rocks glued to paper that have a negative cutting angle. And the harder you push onto the wood to get faster cutting with the paper, the grid, the more you're going to push that fiber into the pore instead of cutting it off. Now, a lighter touch with a scraper will help this. You can also use scraper planes and tune them up, or there's an article I did years ago in Fine Woodworking describing how to convert a low-angle block plane to a scraper. And you can play around with the geometry there until you get that perfect control you need without overly turning that edge over or overly turning the chip over to press too hard against the wood so that you force the wood down into the pores where it's open. But that's the primary difference, is the downward pressure, the overcompensation of a scraper, overcompensating the lift of a knife or a plane by pushing too hard down. There's some balance in there between lift and down that you get a perfectly controlled cut with no tear out and no need to sand afterwards. So if that didn't answer your question, let me know and we'll try again another time. So John Rue asks about steam bending, and the question is a long one, but the idea is John's making canoe paddles, and I did look at your paddles, and they're beautiful, by the way. And I don't really understand the ergonomics of paddling, so I don't understand the relation of the curve you have to the function of the paddle, but it doesn't matter. In general, steam bending is vulnerable to moisture. If steam bending gets wet, it can straighten out a little bit. So it's probably not the best solution for your paddles. Steam bending also is not quite as strong for the volume of a given species as bent lamination is. Bent lamination, given the exact same piece of wood, if you were to do a bent lamination of ash and a steam bend of ash, the bent lamination is going to be stronger. That means in a paddle where you've got to deal with strength and weight issues, you're going to have more wood in that paddle if you're steam bending it, just to have the same amount of strength as you would in a lamination. So it's going to be a heavier paddle. So I don't think steam bending is going to solve the problem. The other thing is, you're talking about using ash and sassafras. And one of the things that seems to be prevalent in the world of woodworking, and probably every other word where we play with materials, is that we look at a material and we like to think of it being consistent from sample to sample. And wood is anything but. Within a single ash tree, you're going to have a lot of variables in strength, elasticity, and stiffness. Typically, the lower you are in the tree, the closer it is to the ground, the more elasticity it has, the heavier it is, and the stronger it is. It's also a little bit more difficult to work and a little bit more split resistance. That degree of variation varies from tree to tree, but it's fairly consistently true in my experience that the closer it is to the ground, the tougher it is, and the stronger it is, and the heavier it is. And that's because it has to be, because the tree's getting tossed about in the wind, and where it's connected to the ground is where it's most stressed. So it has to be flexible there, it has to be strong there, and those things mean that it's going to grow to be heavier there. Typically, faster grown woods are in ring porous hardwoods, and sassafras and ash are both ring porous hardwoods. It tends to be that your odds favor faster grown wood being more elastic and stronger. That means a secondary growth being a little bit more suited to a more flexible, lighter weight for its dimension. I said it's stronger and heavier, but I think you're going to have, for the same strength, you're going to be able to have a thinner paddle if you go with a stronger, more elastic sampling of the species you're working with. So by being more careful in your wood selection, you can make a big difference in the performance of these paddles. You might be able to even change the dimension of not only the strips that you're laminating together and get a tighter radius bend, but you might be able to change the dimension of the overall paddle and weight of the paddle itself. The more laminations you have, the stronger the piece is. So it might be that you could lighten it up and make it more flexible by having more laminations. These are things to experiment with, but I wouldn't leave the lamination process. I think that's probably the best one for you. Steam bending is a whole other journey, and there are good reasons to learn that, but I think you're on the right track already with this. Just might need to change your wood selection and experiment with different thicknesses of your laminations. And I think we've got one more here, don't we? Let's see. Oh, we talked about did I cover all 4 of these? Glue starved joint, finished cut, and yeah, I guess I burned through those. I thought I was going to have a hard time containing myself here. So, have there any other questions come in? Because I can elaborate on some of these things that I
have one, and I'm trying to understand a little bit better. I was asking him to write his full question out one more time so that I can better explain. He was asking, so how can we have small piece of steamed wood? Those are not thin. And then he said, and I said, can you be more specific? He said, for thick wood, and those are not long.
Is that John Ruff?
No. To be bent. And then he said, for example, for Russian wood, that's what we call it here. So that's why I was asking him if he could write his full question out, which he's probably doing right now. But I was trying to figure out what he was referencing.
I've talked to a lot of people who are having issues with steam bending, and troubleshooting steam bending at a distance is a lot of guesswork, because everything in the process of steam bending, much like we were talking about everything in the process of cutting a piece of wood, creates a new variable, and what that variable is often not measured. So, the exact specimen of wood chosen is critical. I've had the best luck steam bending wood when the wood going into the steamer has been dried down to 18%, rather than being kiln dried and brought up to 18%. Not ever having gone into a heated drying process, but just air dried slowly down to 18% moisture content. That way it's got, its fibers are still mostly swollen, but it's not full of water. It's like a celery stick that's stale or that's wilted. It's not got its full turgor pressure in there, so it's easy to bend that. So I don't think it'll flop over if you pick it up. But a totally fresh piece of celery will break if you bend it. Wood's not celery, but I think it's a useful analogy. If the wood that you're trying to bend is too green, you're more likely to rupture the cells on the compression side. So bringing it down to 15 to 18%, sometimes 20% is fine, helps your success rate. Making sure that you've got a steam saturation in the tank, and whatever whether it's a plywood box or a stainless steel insulated cylinder, I don't think makes any difference at all in terms of the performance of the steam. It makes a difference in the efficiency and safety of the process. But if your wood's going in the steamer at 18% moisture content, you're getting full saturation of the steam. Another thing that can help your steam bending success is at the end of the cycle. Say if you're bending an inch square piece and you've steamed it for 50 minutes, spray the inside chamber of the steam area and the wood with cold water. Just saturate that wood really well. Close it back up and let it reheat for about 20 minutes. What that does is it really saturates the surface fibers. They're not going to go back up to 25% or 40% moisture content, but they're going to saturate them and make them more easily deformable. I've seen a huge difference in this, particularly with walnut, when I'm getting a lot of compression wrinkling on the inside of the bend. And I'm almost always bending with a strap, so I'm doing a compression bend. That means the strap, but there's a steel strap on the outside of the bend, wood blocks on the end, and as I bend that around, those wood blocks are pressing against the end grain, putting the piece into compression. What that does is it eliminates a lot of the expansion on the outside of the part. Expansion is where the fibers are more likely to separate, and it's that expansion rather than the bending or the flexing that causes failure. The flexing is what causes expansion because the wood's not compressing all the way. But in a strap bend, where you've got those blocks on the end and then they're pressing against the end grain of that part, you're putting most of the wood into compression and eliminating a lot of that expansion on the outside. So when you do that, you need to have the wood plasticized enough that it can deform in a way that doesn't create sudden wrinkling or sudden compression failure. Another thing that I've learned recently that helps a lot is if you can support the sides of the parts being bent, in addition to having a strap on the outside and a solid form on the bottom. But if you have the form and the part itself the same dimension, the dry wood going into the steamer should be the same dimension as the form, and then clamp sides to your form. The wood will actually get squeezed from the sides because it's swelled up in the steamer, so it's going to be fat going in between those blocks. It's going to get squeezed from the sides, which helps hold the bulging of the sides in, and it'll give you a much more even, uniform compression and a much smoother part. And it seems to increase your failure or your success rate, decrease your failure rate. So those are some of the things. And then sometimes it's just the wood itself. And I've bent walnut that looks like perfectly good walnut, and it just completely failed in the bending process. And sometimes wood just looks really good, and it ain't. You just have to figure that there's going to be at least a 10% failure rate in your steam bending. Make some extra parts. But even with that failure rate, steam bending is, once you're set up with a steamer, is almost always less expensive than bent lamination. With steam bending, you've got to make one part. With bent lamination, you've got to make 15 parts and glue them together. So I prefer steam bending whenever I can make that work for the design I'm building. So hope that's all helpful. Thanks you all for joining us, and hope to see you in a couple of weeks. Thanks.